Hey class, today we're going to start the first lesson in our gas chapter. And this lesson is going to talk about characteristics of gases and then pressure. Now, you've heard of a gas in other science classes that you've taken, and way back when you were a freshman, we learned about pressure. So let's do a little bit of review and also learn a few new things. So let's talk about some characteristics of gases. Well, gases have different chemical properties, which means they're going to react differently. Some are very reactive, some are not reactive at all. However, although they have different chemical properties, they do have similar physical properties, considering they're all gases. Elements that exist as a gas at ordinary temperatures and pressures are things like helium, neon, argon, krypton, and xenon. They're all monoatomic, which means there's one atom. They don't really bond with anything because hopefully you've noticed that all of these gases are noble gases. Whereas hydrogen, nitrogen, oxygen, fluorine, and chlorine are diatomic, which means there's two of them. These gases are pretty reactive, so that way they bond with each other in nature. They're usually not found by themselves. So you see the two for the diatomic. Elements aren't the only things that can be gases. Compounds can be gases as well. And compounds are generally entirely made up of non-metallic elements. So a common gas that you guys know is H2O, water vapor, CO2, carbon dioxide, CO, carbon monoxide. These are all covalent bonded, or you should say molecular compounds. The last thing to distinguish is there is a difference between a gas and a vapor. This was mentioned in all the way back in integrated science. A gas is something that is a gas at ordinary temperature, so CO2 is a normal gas. However, a vapor is when a liquid or a solid has the ability to turn into a gas. So they're liquids and solids at room temperature, but if you heat them up, they do become in a gaseous state. An example of a vapor is water. Water is generally a liquid, but you can heat it up to make water vapor. So let's compare solids, liquids, and gases. Let's give some more um, characteristics of gases. Now, these characteristics I'm going to give generally are all physical properties. So remember, gases have similar physical properties. One, gases expand spontaneously to fill their container, which means they have no definite volume. Their volume changes based on the container that it's in. Gases are also highly compressible. What compressible means is that you can apply pressure and the volume decreases. This is extremely important in everyday life, and we've seen it in movies or even in real life. If you've ever gone to the store to fill up your balloon, they fill it up using a helium tank. Well, that helium tank is just compressed helium gas. Even an oxygen tank that you guys will see in movies that scuba divers are using, that is pressurized gas. Another thing about gases is that they form homogeneous mixtures. Homogeneous, again, means that you cannot see the different components. A good example of this is air. You can't tell the difference between the gases in air, however, it's still a mixture. When we talk about the arrangement of those molecules, those gas molecules, whereas a solid is packed closely together, a liquid is a little bit spread apart, gases are actually relatively far apart. They move at pretty high speeds unless they collide with one another. So there's actually quite a bit of space in between those molecules. And the last characteristic that I'm going to mention is that gases do not have a definite shape. So again, this is mentioned, oops. Okay, we're back in business. Again, this is mentioned as an indefinite shape. So it's going to take the shape of whatever container that it's in as well. We're going to start off now talking about pressure. Pressure was something talked about a long time ago in integrated science, so let's kind of review it. Well, pressure is the amount of force applied to an area. So, of course, the equation is P equals F divided by A. P stands for pressure. F stands for force. A, notice that it's a capital A, stands for area. Let's go through our units because just like anything, units are important. Pressure is typically measured in Pascal. Force is measured in newtons. And area is measured in meters squared. If you ever need to find area, remember area is length times width. Width. And then over here, I'm going to write out Newton to make sure you guys know what that means. And then over here, I'll write out Pascal. Now, gases exert a pressure on any surface they come in contact due to its mass. Everything on Earth experiences a gravitational pull, and due to gases' tiny masses, they have kinetic energy. So kinetic energy is energy of motion. This energy overrides that gravitational forces, so particles that make up our atmosphere actually don't fall and pile up on our Earth's surface. They can float around. But remember, atmospheric pressure is the force exerted by the atmosphere on a given surface. In integrated science, you learned the atmosphere at sea level was about 100 kilopascals, or we like to say 101 is what your integrated science textbook says. If we were to change that to pascals, it's 1.01325 times 10 to the 5th Pascal. When calculating atmospheric pressure, you notice that force was part of that equation. Now, force has its own equation to find. The force, F, is exerted on any object is the product of mass and acceleration. Notice here that we have another A in our equation, but it's lowercase. And again, it means something different. So force, of course, F means force, measured in newtons. M is mass, and A is acceleration. It says the acceleration of Earth's gravitational is 9.8 meters per second square. So that's what you're always going to plug in for acceleration anytime we're talking about Earth's atmospheric pressure, because that's what it's being pressured on it is Earth's gravitational pull. And the SI unit for force is Newton. We've mentioned that. Now, Newton is an abbreviation or a shorthand version of saying kilograms times meters per second squared. Well, if acceleration is 9.8 meters per second square, that means in order to use this equation, your mass has to be in kilograms. Has to be. So keep that in mind. So if we go back to the equation that we've learned, pressure equals force divided by area, and we know that pressure is a force exerted over an area. I've already mentioned that the SI unit is Pascal, which is newtons divided by meters squared. However, this isn't the only unit for pressure. You have things like the bar, PSI that you're going to find in tires, pounds per square inch, atmospheres, and even millimeters per mercury. So over here are going to be a few examples. I'm going to walk through one of them and I'm going to have you try the others. So over here it says calculate the pressure in pascals produced by a force of 547 newtons acting on an area of 4.0 meters squared. Again, pressure equals force divided by area. We have to make sure my units are correct. So if I'm plugging 547 newtons in for force, I have to make sure my unit is newtons, and we're good to go. Our area, it says, is 4.0 meters squared. So over here, make sure my unit is in the correct unit. Meter squared is the appropriate unit. So when you go and divide those, you get 136.75 Pascal as your answer. So why don't you go try this one? It's going to be a little bit different, but let's see if you can get it. Okay, it says the pressure of a gas contained in a cylinder with a movable piston is 324 pascals. The area of the piston is 0.5 meters squared, and it wants you to calculate the force exerted on the piston. Again, we're going to use the same equation pressure equals force divided by area. However, you probably noticed that you were given different criteria. 324 Pascal gets plugged in for P, X gets plugged in for F, and 0.5 meters squared gets plugged in for area. Hopefully you check these units and make sure that they were correct and in the correct units. And when you go, you can solve for X. 324 times 0.5 equals X. So that gives you the answer of 162 newtons equals X. So how did you guys do? Now we're going to try this example because it's going to take into account both equations. So again, it's going to take into account both pressure equals force divided by area and force equals mass times acceleration. It says find the pressure in pascals of a stand that has a mass of 478 kilograms and an area of 25 meters squared. Well, over here, pressure, I'm trying to find. I know my area, but I don't know my force. So I have two x's in this equation that I don't know. So I can't use the first equation. For the second equation, I don't have F, but I do have M. And then remember, A, acceleration, is always going to be due to gravity. So you do know that number as well. So here you can just plug in what you know. 478 kilograms. Make sure this is in kilograms. If it is not, you have to change it. Times acceleration due to gravity, 9.8 meters per second squared, gets me a force of 4684.4 newtons. Now this gives me the force, but I want pressure. So what I can do with this force is plug it back into this pressure equation. So pressure equals my force divided by my area, and my area is in proper units. So I can go ahead and divide this and get 187.376 Pascal. So right now I want you to try this problem right here. It says in the pressure in Pascal, find the pressure in pascals of a shelf that has a mass of 284,000 grams and an area of 36 meters squared. Okay, let's see how you find the answer. If you've noticed right off the bat, this is in grams and we want it in kilograms. So to go from grams to kilograms, I'm going to move my decimal 3 places to the left, or you could have divided by 1,000. So you should have started out with 284 kilograms. Now remember, my two equations are pressure equals force divided by area, and then force equals mass times acceleration. So just like the previous problem, we're going to use this mass times acceleration to get me my force, 2783.2 newtons. And then we're going to take this force and we're going to plug it into the force of our pressure equation. So pressure equals 2783.2 newtons divided by your area, which the equation gives me is 36 meters squared. It's in the correct units. So when I go ahead and divide this, you should have gotten 77.31 repeating pascals. Now, since pressures are not only found in pascals, we actually have to learn how to convert between pressures. Gas pressures are usually expressed in atmospheres, pascals, kilopascals, torrs, and like I said, you need to be comfortable converting. Common conversions are 1 atm will always equal 760 torrs. These values will always equal 101,325 pascals. All these values are going to equal 101.325 kilopascals, and all of these are going to equal 1.01325 bars. So here I have a couple practice problems. I'm going to do the first one for you to kind of show you the conversion. It's what you've been doing. And then you're going to complete the bottom two. So over here, whenever you have a conversion, you always start with what you know. So 0.357 ATM. If I want to cancel ATM, it's got to go on the bottom. And I put the unit that I want to get to on top. So my unit is torr. Now I have to figure out what is the numbers in the relationship. So I'm going to go back and look at that conversion on the previous page. Well, here it says 1 ATM is 360 torrs. So 1 ATM, oh, not 360, 760 is 760 torrs. So I've canceled ATM. I'm left with torrs. I can multiply these two values, and hopefully you get the answer 271.32, and my unit is torrs. So how about you guys try the other two, and then we can check your answers. Let's get started. Again, you start your conversion with what you know, 660 torr. You put what you're trying to cancel on the bottom and what you're trying to get to on top, so ATM. If you look at that conversion, we've used it. 1 ATM is 760 torrs. When you divide this, you get 0.86842 ATM. How'd you do on that one? When you go to do the bottom one, you are starting out with 147.2 kilopascals. We're trying to cancel kilopascals, so we're going to put that on bottom and torr on top. We know that torr is automatically 760, but let's go look at our kilopascals. If torr is 760, our kilopascals is 101.325 right here. So 101.325. When you plug this into your calculator, you take 147.2 times 760 divided by 101.325, and you get 1,104.09 torrs. The last section of this talks about a barometer. A barometer was invented by Galileo, and it showed the atmosphere has weight. What he did was he had a glass tube, and he closed it at one end and filled it with mercury. And then he inverted it, which means he turned it upside down into a dish of mercury, and it created a vacuum at the top. Now, air pressure forces mercury to travel up that tube, and the difference in the heights measured in millimeters, so height is h, is the atmospheric pressure. So 760 millimeters of mercury equals 700 torr equals 1 ATM. This again was the first machine to demonstrate pressure, and now any machine that calculates pressure is called a barometer. So that's the end of the lesson. Let me know if you have any questions, and I'll be more than happy to help. You guys have a good day.